In addition, the design requires a burner chamber that is sealed with the flames from the burners not visible to the technician. This removes one of the greatest indicators used for us to determine when a furnace might have a cracked heat exchanger. Not having this ability to visually monitor the flame, in my opinion, can be potentially dangerous for you, the customer. So in 2015, both SCA and SJV mandated that the manufacturer build a furnace that reduced the current allowable levels of NOx by 65%. This is how the ULN furnace came about. Because no such furnace currently existed, they gave manufacturers 4 years to build such a furnace. In the interim, heating and air contractors like myself were allowed to continue installing standard furnaces and pay a mitigation fee for homes in the SCA or SJV territories. However, these air districts put a hard date to completely ban standard furnaces, October 2019 for SCA and April 2020 for SJV, after which they would no longer allow a standard furnace to be set and pay a mitigation fee. They required all furnaces that are replaced be ULN in these districts. Subsequently, the manufacturers dutifully complied and designed ULN furnaces, or at least a few did. Many brands, instead of developing their own, bought their design from other manufacturers. In 2018, the first few pilot furnaces were being installed. These were installed in homes and being tested. That's when I began to hear the stories from the contractors installing them. These contractors were saying that the new units were having multiple problems. About the same time as I was hearing these stories, I attended training on the upcoming release of these new furnaces, and after that training, I could easily see problems with them myself. At the trainings, I learned that these ULN furnaces had a narrow band that the gas pressure had to be set to, and while standard furnaces have a much wider band of pressure. What makes this bad is the fact that if the gas line going to the furnace is not sized adequately, problems will arise when the furnace is running and the water heater or the gas stove is running at the same time. The gas pressure could drop on these other appliances and drop the gas pressure out to that narrow band or range that it needs to be operated in. In addition, the design requires a burner chamber that is sealed with the flames from the burners not visible to the technician. This removes one of the greatest indicators used for us to determine when a furnace might have a cracked heat exchanger. Not having this ability to visually monitor the flame, in my opinion, can be potentially dangerous for you, the customer. And finally, since this was first generation and not a tried and true technology, combined with all the stories I heard about them, I made the decision not to set ULN furnaces. We advise our customers to install a heat pump when it comes time to replace their system. Unfortunately, I am talking from experience about the problems with ultra low NOx. Even though we advise our customers to stay away from ultra low NOx, does not mean that all customers took my advice. Being in business means that we would do what the customer desires, and in some cases, this meant installing a ULN furnace. Every ULN furnace we installed has had some problems. The biggest problem is how low we have to dial that gas pressure down to mitigate a harmonic sound that these furnaces would make when operating.
Are you ready?
Okay, here's a short video of what it sounds like.
Focus in on it, focus in. Okay, that went away. Wow, that is loud. Let me
As you can see, it is deafening and sounds like a smoke alarm going off. But that is not all. After adjusting the gas pressure to eliminate the sound, we've been finding that the efficiency of these furnaces are no longer within specifications. The efficiency drops from an 80% down to around 66%. That means that the customer is now wasting 34 cents on every dollar that they spend for heat. This loss of efficiency alone should keep you from setting an ultra low NOx furnace and switch instead to a heat pump. Furnaces use AFUE, while heat pumps use HSPF, or Heating Seasonal Performance Factor, to rate their efficiency. However, a better matrix that we can compare operating costs between a furnace and a heat pump is the COP, or Coefficient of Performance. The COP is the amount of BTUs that a heat pump will produce divided by the power consumed, or wattage. Since we know how many BTUs to watts, we can determine how much it costs to produce a million BTUs at a given COP. As for natural gas, it is sold by the therm. Whereas a therm is equal to 1,050 BTUs, we can use this to calculate the cost for a furnace to produce a million BTUs and then compare that to the heat pump. A few years back, I created this chart in order to compare the cost to produce a million BTUs using LPG, natural gas, and a heat pump. And as you can see, it costs less to produce a million BTUs with a heat pump than it does for a 95% gas furnace. In addition, several utilities like SMUD, MID, and TID reduce their electric rates in the winter, which equates to even more savings if these utilities provide your electricity to your home. I want to make it clear, we decided not to use ULN furnaces and switch to heat pumps, not only because we were trying to avoid potential problems that ULN furnaces may have, but we also made this decision because it makes economic sense to use a heat pump, as they are cheaper to run. If your existing furnace is old, it would be better to switch out the complete system from natural gas to heat pump. In short, heat pumps have been around for decades and are quite efficient. They're definitely a better choice over an ultra low NOx furnace. All right, I hope you found this video informative and you learned enough to make a proper decision on replacing your system with a heat pump that will make you comfortable while also saving you money. If you enjoyed this video, please hit the like and subscribe, and thanks for watching.